Hey everyone, this is TechXtreme, and in this video, I'm going to be sort of doing a continuation on the last video, which was all about adding nodes to a linked list. What I want to talk about today is how you can delete a node from a linked list. So say we have our linked list here, right? Say we have our, one sec. Okay, perfect. Say we have our nodes connected like this. And this is the head. And the following nodes are connected using that next field or that next attribute. What I want to talk about is how we can actually delete a node from this list. And in order to do that, what we've been using to add a node is this temporary variable that sort of, lets itself equal to the head and sort of traverses through the list until it reaches the end, where null is the last one, but it only reaches like the end where say temp.next is equal to null. And then from there it's able to add a node to the list. Well, when we're deleting a node, one way we could think about it is, in order for us to delete a node, we need two fields now. So instead of just temp, we need two fields. And so by using two fields, we can do something where, say, we wish to delete, I don't know, this node here, this node we want gone. Well, what we can do is we can use the temp field again to traverse through the list. So say this is temp, but also we can use a new field that we're going to call prev or previous or whatever you'd like to call it. So there's previous. And so what we can do is we can have the list sort of go, not the list, but rather the temp field go to the specific node that we wish to delete. So here we go. This is the temp field, and we want the previous field to be the one before it. So something like this. And so what we have in temp is something along the lines of this. And then what we have in previous is something the lines of just, well, I'm gonna sort of do a dotted line to represent the first one. The first, say the head of the list, which we've already moved on from, but say this is what previous has. So temp has all of this here, while previous essentially has all of this here. And well, this is important because in order for us to delete the node, what we can do with the temp field is, well, we can move it on, say. So with this node here, we want it gone. So if we reassign the temp field to be equal to temp.next, what we can essentially do is remove this node that we want to delete, right? Okay, so essentially now what we have is our temp field doesn't have the node that we wish to delete, but what's actually the case is the previous field does. The previous field does have the node that we want to delete. It just hasn't accessed it yet, essentially. So we'll call this next, right? So the thing is, how can we get rid of the node within the previous linked list that we have just within our delete method? Well, what we can do is we can say to previous, okay, so for your linked list, I'm drawing the dotted one in full lines for this one, just so that everything becomes a bit more clearer. So what we can say is, so previous is at this point of the linked list. Well, what we can say is, okay, previous.next is now equal to temp, where this is temp. And essentially, to our linked list will now have 3 nodes instead of 4. Because essentially, what we have done is we have removed the node from our list by simply moving it on from the temp, using the temp fields that we have. So we essentially just took this temporary field, or whatever you want to call it, and we shifted it up using next. So essentially it just cordoned it off, and then from our previous field we also cordoned it off using prev.next, and essentially we were able to merge these two together using the next field, which allowed us to have this here. So how do we go about coding that up? Well, that's what I hope to show you today. So let's open up our code that we have so far. So in continuation from the last video, our code remains the same. Nothing really has changed, bar me messing around. So I'll remove this part here, and essentially our code is the same. So within our node list, we can now create a delete node method, which will look a bit like this. So we have public void delete node. And obviously we'll have the node that we wish to delete within that field. So first thing we have to consider is, well, what if this node that we wish to delete is at the beginning of the list? Well, we can check for that by comparing, because this is important, because if you said something like if node is equal to head, what that will do is it will actually check the where both are stored, and it will check sort of hexadecimal value of where they are stored within the memory registers. And so if we said if node is equal to head, that's what's going to happen. So it may turn out that this will say false, and it won't run the code within it. So how can we fix that? Well, we can compare, because we've used integers in our node.java. We can actually compare this number field with the number fields that we have within our method. So if we say something like if node.number is equal to head.number, what we wanted to do is we wanted to just simply bring the head up to head.next. And also we want to return, because we don't want it to run the rest of our code, because the rest of our code is thinking of different scenarios. So below that code, we will have something like, well, first we'll have our two fields instead of one. So we'll have node temp. We'll let that equal to head. And then we'll also say, node prev is equal to new node, just so that we can instantiate it. You could let it equal to null. I'm just going to let it equal to new node, because it's just so that I can instantiate it to use it within our code. So after we have our fields, we can essentially use our while loop. And this condition that we're going to have in here is going to be something along the lines of while temp dot number. Now we have to specify it this time, because we are not looking to just traverse through the list. We are looking to actually do something with the list. So this is important. So we can say while temp.number does not equal to temp, not temp, node.number. What we wanted to do is, well, first of all, we wanted to assign the value of prev equal to temp, and we also want it to move through the list. So we'll say temp is equal to temp.next. So what happens here? So during this while loop, what we'll do is, first of all, we'll assign the value of prev to be temp, and then we'll move up the list using temp is equal to temp.next. When the condition is met to where it compares temp.number to the node that we wish to delete, once that condition is met, it exits the loop. So essentially temp is equal to the node, i.e. we found it, and prev is equal to the one before it, because it was assigned temp before temp was reassigned, if that makes sense. So after it finds the node, what do we want it to do? Well, to make sure that it actually has found the node, because what sometimes can happen is, say we say, okay, we want you to delete a specific node, and it can't find that node because it doesn't exist within the list, right? So what it will do is it will go right to the very end of the list, and it may equal to null, it may equal to a random node that we weren't expecting. So this if statement sort of covers that ground, and we can say something like if temp.number is equal to node.number. We wanted to do a few things. So as specified within that sort of sketch I did, we want the temp, which is our node that we want to delete, we want it to be shifted up by 1. But before then, well, actually no, we'll say temp is equal to temp.next. So we've shifted it up by 1. And now we will reassign the value of prev.next, which before then would actually be equal to the node that we wish to delete, and we'll have it equal to temp. And essentially we have our delete node method complete. So all we have to do now is to test it. So first of all, we have the numbers 1, 2, and 25,000 added to the list. Let's run the code just to make sure that works. And as we can see, the add method still works, which is great. But now, say within our node list, we want to delete node. We want to delete, say, new node 2. We want to delete that one. Now, if we run this code, so say from here to here, or rather we'll move it down a bit more. What I'm essentially doing is traversing through the list again, just to test, did it delete the node that we asked it to delete? And hopefully it does. And it does. So as we can see, we have the number 1, we have the number 25,000, and it reaches the end of the list. I exited that while loop there, and it printed out this statement. Now say I change this number to the number 1. Does our code still work? It does. And what about the number 25,000? What happens there? It also deletes that. So essentially, it covers all grounds. It covers the first node, the beginning node, or any node between there, because we have 4 nodes, 5 nodes, 6 nodes, whatever amount of nodes you got in your list. We want to be able to find a specific node, albeit if you have replicate nodes, what will occur is it will delete the first node. So if you find out you're trying to delete a specific node and you have multiple nodes that have the same sort of attributes, then you may want to consider tightening up the code or making the numbers unique so that when you're going through your linked list, you don't have that issue. But for this demonstration, I just want to sort of show how we can get a list a node list working, and also with the add methods and the delete methods in there. So I hope that this video helped you understand what's going on within this delete node and how we can actually delete a node from our list. If it did, please give this video a like, comment down below, and if you really want to, please subscribe, and I will see you in the next one. Have a wonderful day.